So plumbing just needs to run downhill, right? What's the big deal?
Hi, I'm Brian.
So let's start with a couple of big caveats here. I am not a plumber. I am not a building code expert. So I've just taken on a particular task here, which is to run my main building sewer line from my house to my septic system. So, and I'm in Cochise County. So some of this will be a little bit specific to that stuff, but it should apply fairly generally. Again, I'm also not gonna cover, this won't be a complete kind of plumbing tutorial. I'm not gonna cover every little detail of plumbing, like things like venting and stacks and branches and things. There are some things that I won't really deal with until I get kind of inside the house. Again, this is just one job, to get the main sewer line from the house to the septic system so that I can take my next step, which is some foundation preparation. So, but even though this is specific to this particular job and my particular area, I believe that most of the topics and information should apply pretty generally to everybody's system. And we'll talk about that later, plumbing system, if you want to learn a little bit. So another thing I want to mention is that I'm in Cochise County and I am on the opt-out permit. If you don't know what that is, you can look at some of our other videos or look it up. But basically it means that we won't be inspected really when our house is done. We will have one inspection, which basically just checks to see that we're positioned properly on the property. It'll check setbacks to property lines and washes and things like that, and they'll check a couple other things, but really outside. They're not going to go in and do a plumbing inspection, electrical inspection, or anything like that. But even though we're on that permit, I want to mention that when you kind of sign up for that permit, you agree that you will build to code. So, and I personally will choose to build the code, at least as much as possible, as much as I understand it, and as much as I can. I will only deviate if there is if I really understand what the code is about and what it's trying to accomplish and why I specifically want to bend or break some rule. There may be those out there that say, I don't care about code, especially if I'm on the opt-out permit, or what they don't know won't hurt them. That's perfectly fine. You're free to do that. But I will try to stick to code as much as possible. So with that said, let's jump into it. All right, so let's talk about codes a little bit. So here in Cochise County, Arizona, they have adopted the 2012 International Building Code, which in turn for residential buildings has points to the 2012 International Residential Code. So that's what Cochise County has adopted with some amendments. I think this is a pretty standard procedure, I believe. So these codes are written fairly generically to apply to all areas and things. So what each location will do is they will publish a list of amendments that will be specific to kind of your geography. So things like frost lines and snow loads and wind speed. So I think it's pretty common for any location to say, we've adopted this code with these amendments, that are specific to our area. So we're working off of the 2012 International Residential Code. And a note about codes in general, at least for me personally, they're a little tough to read. They read kind of like legal documents. They can be hard to read, especially without a specific goal in mind, a specific project you're trying to kind of work on, or some background knowledge, a little background knowledge at all. So if you just dive into a code document, which, believe me, I tried, just to kind of read it cover to cover, everybody's different, but I didn't get a whole lot out of it, I'll say. So, but the good news is that when you have a specific project that you're working on and you have a specific goal you're trying to accomplish and you have a little bit of background knowledge, when you start to dig into the code, you find things in the code that make a lot of sense, that you understand, that now when you read them, they make sense to you and you can understand why they're that way. So the bottom line is a combination of some Googling, some YouTubing, and the code itself, the code document itself. When you put those things all together and you're working on a specific project, they can be very helpful and they tend to make sense. At least that's been my experience. So just a little bit about my specific project again, which is getting my main sewer line from my house to an existing connection for my septic system. It turns out when we bought our property here, we already had septic on the property. It was permitted and installed, all legally and by the book before we bought the property. So there's an existing hookup which we're actually using for our RV that we'll be connecting to with our main sewer pipe from the house. So I'm going to touch on a couple of topics here. One is the material we'll be using, the type of piping that we'll be using, because you have some choices. The joints that we'll be making with that piping, the sizing and slope of that pipe, and then a little bit, lastly, a little note on T's and Y's, which are some of the fittings we'll be using. So those are the things we're going to touch on. So as we talk about these specific pieces and their where they're referenced in the code, I want you to keep in mind that I am using the 2012 version of the IRC. So I will be referencing some section numbers and table numbers that potentially, if you're looking at another version of the code, those numbers could be different. I think all the information will still probably be about the same, but it could show up in a slightly different location. So some of these numbers could be a little different if you're looking at a different version of the code, so just keep that in mind. And just another note about kind of navigation through the codes. These sections and table numbers, they will tend to kind of start with a letter. In this case, since we're dealing with plumbing, they'll start with P. And after that, they'll be followed by a number. For example, 3002 is the first table I'm actually going to reference. That 3002, that the first two numbers, the 30 in there, references the chapter of the code, and then following that is kind of sections and subsections. So just an easy way, if you ever see references to table numbers or section numbers, the letter will kind of put you in the section of the code that we're talking about, whether it's plumbing, electrical, whatever, and those numbers can kind of point you as well. So those first couple numbers will take you to a chapter and so on. So that should help you find things in the code. So first, about the piping material that we're going to use. There are a lot of choices, and they're spelled out in the code. Table P3002.2 gives you a list of the allowable piping. This is specific to the building sewer line. So there would be other tables for other applications, like the drain line that's inside the house and venting and things like that. So and various fittings that you'll use. So there are other tables that talk about those things. I just wanted to show one example of the table that lays out the choices for the building sewer line. Two most common, I think, are ABS and PVC. So I mentioned that we're connecting to an existing septic system and septic connection that was here when we got here. It happens to be 3-inch Schedule 40 PVC. I would have just continued that with 3-inch Schedule 40 PVC the rest of the way, but in my area I just didn't have a whole lot of luck finding the 3-inch Schedule 40 PVC and the fittings that go along with it. So I chose to switch to ABS. So from the connection point that we have existing, I'm going to transition to ABS, which can be done. We'll talk about that in a minute. But so I'm going to run 3-inch Schedule 40 ABS the rest of the way. So since I mentioned the transition from PVC to ABS, it seems like a good time to talk about some joints. So since I'm kind of focusing on plastic piping here, let's talk about how plastic piping is joined. So generally, all plastic piping, whether it be, again, the most common PVC and ABS, they're joined with a solvent cement. Some would call it glue, but it's also known as solvent cement. And in the case of PVC, you would use a primer as well. So for PVC, you use a primer and a solvent cement. And for ABS, you just use a solvent cement, a different kind of solvent cement. So that's a key point to make, is that each plastic piping has its own solvent cement that is meant to join it. And that's because it's not just glue. It really does chemically bond the plastics together. So it actually does a little bit of melting, and the plastics actually join. They chemically bond. So that's an important thing to know about these joints, because when it comes to the transition to changing between PVC and ABS, which I'm going to do, the code specifically has a section, that is section P3003.2, which lists some prohibited joints that you're not allowed to make. And one of them is, quote, solvent cement joints between different types of plastic pipe. So what they're saying there is you cannot, per the code, you cannot solvent cement join PVC and ABS. So the answer is actually, well, the reason I think the reason they say that, I haven't gotten a good reason, the code doesn't usually talk about why things are the way they are. But the reason I've gotten is, again, because of that idea that each plastic has its own solvent cement that will chemically bond it to another piece of that plastic. Even though they do make a solvent cement that is specific for the transition from PVC to ABS, you may be familiar with it. It is called a transition cement, and it's generally, I think it's green, and it is for that purpose. Even though that solvent cement exists, I think the code authorities have some concern that joint is not really trusted. Now, I've seen a lot of information out there that joint is not really known to fail. So this is one of those points where you could go, well, I don't care what they say. But I just wanted to point out that the code does say not to solvent cement those joints together between PVC and ABS. So the answer, that the way you can join them, even though you can't use a solvent cement, you can use a flexible coupling, which most people will know as a Fernco. That's actually a brand name, but that's a brand name of a flexible rubber joint coupling. So something called a Fernco, and that is what's known as a mechanical bond as opposed to a chemical bond. So that's what I'm going to use for the transition from my PVC to ABS. So next, let's talk about the sizing and the slope of that pipe. So I mentioned earlier that I'm connecting to an existing connection to my septic system, and it happens to be 3-inch PVC. So when somebody heard that, that might freak you out a little bit, and it actually freaked me out a little bit for a while, because I believe that most normal homes use a 4-inch sewer pipe. So I was a little worried, is this thing going to be all right? Is it going to clog up? Are things going to get stuck? So at this point, it makes sense to kind of take a little tangent, not too much, but to talk about drainage fixture units. And these are referenced in the code. There is a table in the code, P3004.1, which talks about how to assign drainage fixture units or count up drainage fixture units. And the idea is they will use this number of drainage fixture units in many other calculations about the sizing and slope of your piping. So, for example, a kitchen sink counts as 2 drainage fixture units, probably because kitchen sinks usually have 2 bowls, right? A lavatory, a bathroom sink, counts as 1 drainage fixture unit. So you can take a look at that table and add up the things you're going to have. So the good news here is we're keeping it pretty simple, right? We're building an alternative house. It's only going to be 1 bedroom, 1 bathroom. There's not going to be a whole lot going on. So what we're going to have, it turns out, is a kitchen sink, a bathroom sink, a shower stall, a toilet, potentially a dishwasher, and a clothes washer. So when I added all those things up, I only got 12 drainage fixture units. So there's another table, P3005.4.2, which shows how to kind of apply that drainage fixture unit number to size and slope of pipe. So you can take a look at that table and see kind of where you fall on there with how many things you're going to have in your house. Now, you'll notice that with my number of 12, which is really small, I could get away with a very small pipe. I think on that table I could probably even get away with 2-inch pipe. But if you're thinking, just logical thinking here says, but wait, what about a toilet? I mean, a 2-inch pipe seems really small to use when you've got a toilet involved, right? So there is a note on that table, note B, which specifies that any of the that note is applied on any of the pipes less than 3 inches. So 2.5 to, I think it goes down to, goes a little farther. But basically they say that anything under 3 inches says no water closets. So basically no toilet. So if you're going to have a toilet, no matter what your drainage fixture unit number is, you need to use at least 3-inch pipe. So it turns out for our situation with our 12 drainage fixture units, we will be using 3-inch pipe. And, I'm not freaked out about that anymore because of these numbers. We're nowhere near what 3-inch pipe can handle. So the other question is slope. And there's another table that talks about slope. Slope is mentioned in the table I just talked about with drainage fixture units. But there's also another section which specifically talks about the slope of this pipe. That is section P 3005.3. It talks about the required slope. And something interesting to note that I didn't know, I think it's fairly common knowledge when you talk about plumbing with people, that you want your sewer line to slope 1/4 inch per foot, or 1 inch per 4 feet. I think that's fairly common knowledge. That'll be one of the first things. If you ask anybody, how much do I slope my sewer line, you're probably going to get that answer pretty quickly. And that's fine. But one thing, when I read the code, something that I found interesting was that for pipes of 3 inches or above, the code actually says that you can do 1/8 of an inch per foot. So it's just something you can get away with. It turns out I'm actually going to do 1/4 inch per foot. And you'll notice in that other table that talked about drainage fixture units, it gives different slopes. It gives different values of what you can handle based on the slope. So, but I just found it interesting that you're actually allowed to do 1/8 of an inch per foot, which I had never heard before for pipes 3 inches and above. Another general note about sloping, if you didn't know this, but it makes sense when you think about it. The logic behind the slope is, you don't just want to just point your pipe down, right, and say, hey, as long as it's going down, it'll be fine, right? As long as it's sloped downward, that's fine, right? Well, there is such a thing as too much slope, and that is because if you think about it, especially if you have a toilet involved here, there are liquids and solids flowing through this pipe. So if you have liquids and solids and you send them down a pipe that's really sloped down, right, quite a bit, the liquids will outrun the solids and leave them behind, and they won't flow. So the liquids are meant to carry the solids, and the problem is if you slope too much, your liquids will actually outrun your solids. That's something that if you've ever spent much time in an RV, you kind of get to know that the combination of liquids and solids, you have to be careful with them, right? You don't want your liquids and solids to get separated from each other. The liquids, their job is to carry the solids. So just keep that in mind when it comes to slope. And finally, I just want to talk a little bit about some of the fittings, T's and Y's specifically. I want to talk about it because it can be overwhelming. There are a lot of different kind of incarnations of fittings, of connections between pipes. And it can be pretty overwhelming when you're standing in the store in front of this mass of pieces, right, to fit this stuff together. And you're like, why does this one have a little bend in it between these two pieces, but this one doesn't? A T, for example, where things come together like this. How come one has a curve kind of built in there and another one doesn't? And why is this one longer and this one shorter? And that stuff kind of blew me away for a while, I'll admit. So it can be a little overwhelming. So I wanted to talk about it. So generally, and you'll hear the term sanitary T. The idea is to assist the flow, right? So when you see curves in a lot of those things, even if it's a piece that obviously a bend is going to be curved, but with things like a T, a T can just be two things put together, and you might not understand why they build in a little bit of a bend inside the plastic to assist things. So there will be a lot of people out there who will claim, which they did to me, and I believed it, and it ended up getting me into trouble. I actually bought some of the wrong parts, and I'm going to switch. But many people claim that a sanitary tea, its purpose is to assist the flow of solids. I was actually told at the store that the use of a sanitary tea and that curve that's built into the thing is, he said, you use that if you have solids, and you can use a regular tea without the curve if it's just liquids. That is not true. I feel fairly strongly that that is not true, because I've done some reading and then the code sort of backs it up. The idea is the tea, the sanitary tea, which is kind of the shorter version. It's not elongated, and I'll show a picture of it. The sanitary tea has that curve built into it. That curve is actually meant to assist or facilitate building a vent into your system when you put that piece in place. That piece is meant to be used to transition from a horizontal flow to a vertical flow. So basically you're going across and then you want to flow down. You're connecting to something, you want to flow down, and that bend should point down. And the reason it kind of is also teed up is so that you can have a vent, I believe. Now, I'm not going to get deep into venting here, but I believe that's the reason that piece is made that way. What it is not used for, which I bought it for to start, and I'm changing, what it is not meant for, and the code backs this up. It is in table P3005.1. It didn't necessarily make sense the first time I read it, but now with a little bit of extra knowledge, now that I look back, it makes sense. The only prohibited connections in that table, the two dashes in that table, other than some notes elsewhere, are the using the sanitary tea to go from vertical to horizontal. So if you've got something falling and hitting a horizontal that you want to now send it off to a side, or horizontal to horizontal, so say it's flowing along and you wanted to send it off, kind of sideways. The sanitary tea is not meant for that use, and the code says it, and there's a reason, especially for the transition from vertical to horizontal. So the curve that's built into that sanitary tea is pretty slight, and if you look inside the piece, you can still see the bottom of the pipe even with that curve. You can see the bottom part that goes this way. The reason that's a problem is because as waste, water, liquid, and solid would fall down that pipe and hit and turn, it actually will hit the bottom of that pipe and could splash, and that could get you things start to collect, and that could result in a clog. So that is why that sanitary tea is not meant for that transition. What is meant for that transition is a combination Y and bend. So it looks a lot like that tea, but it's longer and the sweep is more pronounced. And I'll put a picture of it here, but you can't get that falling and hitting the bottom and splashing. So it still has kind of the section at the bottom that will connect you horizontally, and it has the transition to get from vertical to that horizontal, but there is no way for the liquids and solids to fall directly to the bottom of the pipe and splash. They have to kind of flow along that curve. So the correct device to switch, which I will be using, because when we make this run, we will still want to allow for our RV to hook up where it does today, but then the pipe will continue on to the house. So we need a T there. So what I'll be using actually is that combination Y and bend, which will send the RV waste, along the pipe toward the septic without being able to hit the bottom of that pipe and splash, and potentially cause a clog in the future. So that is my little spiel on sanitary T's and Y's and bends and the difference between them and why they're used and what they are and are not for. And the code kind of backs it up. So that's another one of those things that when I read it before knowing this information, I didn't really understand that table, because it just has a bunch of X's in it and things. But after you understand, and this came from a little bit of Googling and seeing people explain what these things are for, that it started to make sense. And I did not get that information, by the way, at the big box store when I asked that question of which one to use when and why you were supposed to use those. I did not get that information. I actually got some incorrect information. So there's my spiel on that. Well, there's a rundown of my plumbing journey so far, guys. It was a long one, but there's a lot of good stuff in there, I think. I tried to hit the things that kind of overwhelmed or confused me along the way. So I think it'll apply pretty generically to a lot of situations out there. So hopefully you got something out of it. If you like it, please like and subscribe and come back and check our progress. Thanks for watching. See you next time.